Hello everyone, and welcome to today's presentation. I'm excited to have you here as we explore the fascinating world of mobile systems security. Today, we'll be focusing on Lecture 7, which is all about Android reverse engineering. My name is Professor Mahmoud Elkouli, and I'll be guiding you through this session. Over the course of this presentation, we'll cover key concepts and techniques related to understanding and analyzing Android applications. So, let's dive in and get started. Welcome to this section, where we'll explore the learning objectives for our workshop. First, we'll discuss why reverse engineering Android apps is such a valuable skill in today's security landscape. Understanding the motivations behind reverse engineering helps us grasp its importance in identifying vulnerabilities and analyzing malicious software. Next, we'll look at how to set up your lab environment, whether you're using Windows or Kali Linux, to ensure you're prepared to start revering apps effectively. Then, we'll review the essential toolkit needed. These are the core tools that will support you throughout the process, from decompiling to analyzing code. Moving forward, I'll guide you through a hands-on walkthrough, providing a step-by-step approach to reverse engineering an Android app. We'll begin with acquiring the APK, which is the first crucial step. Then, we'll decompile the APK using JADX, which allows us to view the source code. After that, we'll perform static analysis to understand the app's structure and behavior without executing it. We'll also cover dynamic analysis and debugging techniques, which involve running the app and observing its behavior in real time. Lastly, we'll touch on advanced techniques, including obfuscation methods that make reverse engineering more challenging. To wrap up, I'll share best practices for ensuring your reverse engineering efforts are effective and ethical. All of these objectives are designed to equip you with a comprehensive understanding of Android app reverse engineering, connecting each concept to the broader goal of enhancing security and analysis skills. Let's talk about why reverse engineering Android apps is so important. First, malware analysis. By reverse engineering, we can understand what malicious software is capable of, which helps us develop better defenses. Next, there's security research. This allows us to identify vulnerabilities like hard-coded credentials, insecure data storage, or logic flaws that could be exploited. Then, there's penetration testing, where we assess the security of our own applications or third-party apps to find and fix weaknesses before malicious actors do. Digital forensics is another key aspect. By examining apps, we can extract evidence that might be crucial in investigations. Finally, understanding the actual behavior of an app helps us see beyond its advertised features. Sometimes, apps do things behind the scenes that aren't immediately obvious. All these reasons tie back to our overall goal, gaining a deep understanding of app behavior to improve security and trust. Let's talk about setting up the lab environment, focusing on Windows and Kali Linux. We'll be installing a core set of tools that are compatible with both platforms, which is essential for flexibility in our testing. First, there are some prerequisites to keep in mind. Java JDK is a must-have because many of these tools depend on Java to function properly. Then, for Android-related tasks, we'll need the Android SDK and Android Studio, especially for using a DB and running emulators. Python 3 is also necessary, as it powers many scripts and automation tools we'll be using. Now, moving on to the core tool stack. First up is JADX, which is a decompiler. It allows us to convert APK files back into Java source code for analysis. Next is AppTool, which helps us disassemble APKs into Smalley code, giving us a closer look at the app structure. MobSF is an automated security testing framework. It's great for quickly identifying vulnerabilities. Frida is a dynamic instrumentation toolkit. Think of it as a way to hook into running processes to manipulate or inspect behavior on the fly. And finally, Burp Suite, which intercepts network traffic, allowing us to analyze and manipulate data as it moves between the app and the server. These tools collectively form the backbone of our mobile security testing environment. Understanding how they work together helps us build a comprehensive approach to assessing app security and behavior. All right, let's walk through the setup process step by step. First, you'll want to make sure your system is up to date. So you'll run sudo apt update and sudo apt upgrade to ensure all your packages are current and ready for the new tools. Next, installing Java is essential since many of these tools depend on it. You'll use sudo apt install OpenJDK to get the latest OpenJDK version. After that, you'll need the Android SDK and ADB. You can install them with sudo apt install Android SDK, or alternatively, you might prefer installing Android Studio for a more integrated environment. Then, you'll install apt-tool, which is crucial for reverse engineering APK files, by running sudo apt install apt-tool. Following that, JADX is another key tool for decompiling Android apps, so you'll install it with sudo apt install jags-y. Frida is a powerful dynamic instrumentation toolkit, and you'll want to install it using pip3 install Frida tools to enable runtime analysis. Lastly, for managing the mobile security framework, you'll clone the mobsf repository from GitHub with git clone, then navigate into the directory with seed, and run the setup script with /setup. sh. Using Docker for mobsf is often the easiest way to get it up and running smoothly. This step-by-step setup ensures you have all the necessary tools installed to perform comprehensive mobile security assessments, which ties directly into our overall theme of mastering mobile app security testing. So let's talk about how to get the APK for analysis. There are a few common methods we can use. First, you can download it from public app stores like Google Play or websites like AppCure, which host a lot of APK files for public access. Tools like gplakely are quite handy for automating the download process from Google Play. Alternatively, if you have physical access to a device, you can extract the APK directly from it. This involves a few commands. First, listing all the installed packages with a db shell pm list packages. Then, identifying the specific app you're interested in by using a db shell pm path.com example app, which gives you the APK's location. From there, you can pull the APK file onto your computer using a db pull and specify the path to save it locally. Another straightforward way is to source the APK directly from a web source, simply by downloading it through your browser. This can be quick and easy, especially for well-known apps. Now, I want to highlight a best practice here. Always start with a simple, open-source test app, like a basic Hello World app that you build yourself, before tackling complex, obfuscated production apps. This approach helps you understand the process without the added difficulty of obfuscation or proprietary code, making your analysis more manageable as you build your skills. Now let's move on to step 2, decompiling with JADX. This is where we take the APK, which as you know is just a zip file, and extract the readable Java code from it. The command line is pretty straightforward. We use jags with the flag to specify an output directory and then point to our target APK. Once we run this, what actually happens? Well, JADX extracts all the contents of the APK and then focuses on the class's dex file, which contains Dalvik bytecode. It converts this bytecode back into human-readable Java source code. The output directory will then contain the full project structure, making it easier to analyze the app's code. And there's also a handy GUI alternative. Instead of the command line, you can open the APK directly with JADX GUI. This provides a navigable view of the code, which can be much more intuitive, especially if you're exploring a new app. So, this step really bridges the gap between the compiled APK and the source code, helping us understand how the app is built behind the scenes. This slide doesn't contain enough information. That's why we're moving to the next slide. All right, now we're at step 3, static analysis, which involves reading the source code. When you're looking at decompiled code, there are a few key things to keep an eye on. First, look out for hard-coded secrets. These are strings like API keys, passwords, or tokens that shouldn't be embedded directly in the code. Searching for keywords like password, key, or secret can help you spot these quickly. Next, pay attention to sensitive operations. These include cryptography functions, file access, or network calls. Look for terms like cipher, HTTP URL connection, or shared preferences, as they often indicate sensitive data handling or operations that could be exploited. Then identify entry points by examining the Android manifest, XML, which you can decompile with tools like JADX or AppTool. Here, you want to find exported components such as activities, services, or broadcast receivers. Also, check the permissions assigned to these components. These permissions can reveal potential security risks. Finally, be on the lookout for vulnerable code patterns. For example, SQL queries that concatenate user input, cross-site scripting vulnerabilities, or intent injection issues. Recognizing these patterns helps you understand where the app might be vulnerable. Overall, this static analysis phase is crucial because it allows us to uncover potential security flaws before moving on to more active testing. It's about understanding the code's secrets, operations, entry points, and weaknesses, all of which are essential to a comprehensive security assessment. This slide doesn't contain enough information. That's why we're moving to the next slide. All right, now we're moving into step 4, dynamic analysis, which is all about observing the app in action. First, you want to set up your environment by starting an Android emulator or connecting a physical device. Once that's done, use the command adb devices to make sure your device is properly connected. Next, you'll install the app using adb install target, app. This step ensures the app is ready for real-time testing. Now let's talk about some key techniques. One important method is network traffic interception. To do this, you'll set up Burp Suite as a proxy server. Then, you configure your Android device to route its traffic through Burp. Don't forget, if the app uses HTTPS, you'll need to install Burp's CA certificate on the device so you can decrypt and analyze encrypted traffic safely. Another critical technique is logcat analysis. With a DB logcat grep, example app, you can filter the logs to see what's happening inside the app during execution. This provides valuable insights into the app's behavior and potential vulnerabilities. Finally, there's runtime manipulation with Frida. This powerful tool allows you to bypass root checks, disable certificate pinning, or modify function return values on the fly. It gives you dynamic control over the app's behavior during testing. All these techniques together form a comprehensive approach to dynamic analysis, helping us understand how the app works in real time and identify security issues effectively. Now, let's talk about advanced techniques and obfuscation. When the code is intentionally made hard to read, it can be quite a challenge to analyze. There are several common obfuscation tools out there that developers use to protect their code. For example, ProGuard, which is the default in Android Studio, is widely used to shrink and obfuscate code. Then there's R8, which is actually the successor to ProGuard, offering even better optimization and obfuscation capabilities. For more robust protection, some opt for commercial solutions like DexGuard, which provides stronger obfuscation techniques. These tools often employ reflection, string encryption, and control flow flattening to make the code harder to understand. So, how do we deal with such obfuscation? One effective approach is using along with Smalley. This allows us to analyze the intermediate Smalley code, which is essentially the assembler level for Dalvik bytecode. By doing this, we can rename obscure classes and variables into more logical names, making the code easier to follow. Another powerful method is dynamic debugging with tools like Frida. This lets us observe what the code does at runtime, even if it's heavily obfuscated. We can see which strings get decrypted in memory and understand the actual behavior of the app. Lastly, dealing with obfuscated code often requires patience and manual analysis. It's a process that demands persistence, but with these tools and techniques, we can gradually uncover what's happening behind the scenes. All of this ties back to our overall goal, understanding and analyzing the security and behavior of the app, even when it's deliberately made difficult. So, to wrap things up, let's talk about the overall process of reverse engineering. It's really a cycle, starting with static analysis, then moving to dynamic analysis, and then repeating that process to refine your understanding. This iterative approach helps you uncover more details with each step. Next, tools are absolutely essential. Mastering tools like JADX, AppTool, ADB, and Frida will make your work much more efficient and effective. These are the building blocks that enable you to analyze and manipulate apps more easily. When you're just starting out, it's best to keep it simple. Begin with apps that aren't obfuscated so you can learn the workflow without unnecessary complications. As you get more comfortable, you can tackle more complex, obfuscated apps. It's also important to combine different techniques. Use static analysis to identify targets or interesting parts of the code, and then apply dynamic analysis to test and explore how those parts behave at runtime. This complementary approach gives you a much deeper understanding. And of course, always keep ethics and legality in mind. Never reverse engineer any software without explicit permission. It's not just a legal requirement, but a professional one too. Respecting these boundaries is crucial. Finally, to keep improving, I recommend practicing on vulnerable apps like OWASP, MASVS, DVAA, or Insecure Bank2. Reading the FRIDA documentation and exploring example scripts is also very helpful. Plus, exploring projects like MobSF can give you insight into automated analysis capabilities. The more you practice and learn, the more skilled you'll become at this craft.